Hey everybody, welcome in that series of tutorials regarding cloth simulation within Golem. This is the second video where we're gonna explain in details all the cloth material parameter that you can set on your cloth settings within the physics plugin and see how we can inject this within Golem. If you haven't done so, I really recommend you checking the first video we made regarding the overall setup to make sure that all the prerequisites regarding cloth simulation are fulfilled on your side and you don't have later issues. So I went back onto my previous setting. So I'm still with a centimeters character, but refer to the video if you've got other settings on your side. And I kind of erased everything into my scene. So if I just throw the simulation, nothing really happens because I just removed everything. You may have noticed that my arm is keyframed. That's something I kind of really like to do, just to provide a dummy animation which kind of shows what kind of motion and velocity I'd like to inject to my clothes. So while I'm setting it, it's a good way to check that it reacts properly. So let's get started. I'm running the physics plugin. Make sure once again to check the first video regarding the physics plugin and how to install it and how to load it. And whenever I do a cloth simulation, I need to inject to my clothes some max distance. So this is the first step we need to do. So first we need to say this mesh here is going to be a close. So this mesh is just a planar surface. It doesn't have any whites here, but you can have some whites if you want. That's usually advised when you do some cape or some jackets or some clothes on your characters. Nvidia Physics provide plenty of tools to deal with those. Here is just a surface. When you do flags, it's more than enough. So I'm going to select, I'm going to rewind my sim here. I'm going to select, probably rewind it with Nvidia. It has its own control. And I'd like to create a physics closing out of that mesh. Now, if I run the first frame, I'll get a warning message from the physics plugin saying that there's no max distance painting on closing max man-MD flag closing LOD1. Okay. So let's stop this, go back in the first frame, and that max distance is the minimal requirement for the physics plugin for a cloth setting. So I'll show you exactly what does that mean and how we set this. So when we created our cloth node, we end up with a new node within a scene. We can select that node and we can see the casual parameters. It also has a physics group, which has, it's kind of the nucleus here. It has all the global attributes regarding the gravity. So once again, depending on the size of the character, make sure to check the first video. What I like to do when I'm starting a new closing definition is to go into the options here. And especially into the collision option, I'd like to uncheck the slow start. So slow start is just kind of a fade in when the mesh is in this bind position. So it will fade in into the close and it will take a couple of frames to fully be a close stuff. So we're going to lose those frames. So usually I just uncheck this. So when we're going to start the simulation, it's going to be close from the beginning. And it will react, especially if you've got collision, it will react faster. Great. So what about that max distance? It's a data we're going to paint per vertex. So if you want to paint a per vertex attribute, you'll have to go into the physical materials. This is where you're going to define everything which is relative to your close material, how it will react when you're going to provide some motions or some wind. And we're going to paint those. So this is like overall attributes you provide to the whole clothes, and this is like per vertex attributes you're going to provide. As soon as I get started with the paint, I'll get the paint tool settings, the regular paint tool settings, really similar to what Maya provides. You've got the exact same shortcut. If you press B and move your slider, you can control the brush size, and all the relative attributes are going to be the same. I also would like to set up my visualization mode to lines. So when I'm gonna paint stuff, I'll see some lines appearing here. So the lines are pretty tiny here because what I just painted as a value is 1, and my character is in centimeters. So this is the maximum distance I'm allowing for those vertex in both directions. When you paint the max distance, it's going to be along the normal and along the reverse normal. So keep in mind this. You can change this. There's other attributes you can paint. We're going to detail this a bit later. So depending on the size of the character, make sure also that you set up the right range. So here, my value I want to paint are going to be between 0 and 100. So put your visible range between 0 and 100 so you'll have control in that slider for that value here. So let's say I'm not really sure what to do. I'm going to paint a 50 unit max distance onto my character. So let's paint and see what's exactly is going to happen. So from the look of it, well, it looks like it's plenty of displacement for my characters, for my close vertices to go. But the thing is, here 50 means that that vertex here will really move into a wide range. It may go here, there, there. So probably 50 is not going to be enough. Whenever you want to test something, you can use the controls from the Nvidia tool. And so we didn't have the slow start, so this is what we get. And you can see we're kind of, and yeah, obviously I have my animation being forwarded to my character, and you know what, I also have my velocity being displayed, so let's remove this. It's something I like to have in some situation to figure what's going on. So now I can go into my nucleus, physics, clothing, visualization, into the masks, and I can disable this. So let's go back into this. Okay, and see, it looks, I mean, it looks okay, but from some reasons here, I would expect my clothes to, you know, I can feel it's kind of stuck at some situation here. That my vertices here in the bottom of my flag feels limited, and you can see here when I run the first frame, let's probably add some wireframe on it. When I'm here, I can kind of feel my vertices are blocked. Whenever, so also just a side note, I haven't painted any weight, any max distance onto those, so those are considered as constrained, and this is the skinning which are going to be controlling those. So yeah, my issue here is that my vertices seems limited. I can actually show what's the max distance here. So I can ask my system what's my maximum distance per vertex, and from what I can tell here, my vertex, which is here, the distance between that point here, which is the original point, and that point here is probably superior to that vector. So this is why we kind of feel blocked by our unit here. So if you don't really care about, you know, how much distance your vertex can go through, I'd recommend painting a pretty high value so you don't feel limited with this. So let's go back into the first position here. Let's go back into our closing node. Probably let's remove the max distance. Great. And let's go into the paint, and what I really want to paint is probably a 100 unit value. You can see that now I have a full white. It's because I'm painting the maximum value of my range, and obviously has its you know, the same controls than the Maya paint tool. You've got smoothing, you've got floating, you can add scale, rescale, you know, your data, you can delete and paint other values. So you've got the casual controls. If those lines are quite too big for you, you can scale them down so it doesn't go through the full display. And I'm gonna roughly paint my flag here. So now I've painting a distance of 100, and you can see that we now have something we didn't have from the beginning, is we don't have that blocking that we had before. Regarding the way the close reacts when it's waved, maybe we can change some attribute depending on what kind of you know, close fabric you have. So let's jump into the other attributes. So, well, you know what? Before, let's go through the 4 different stuff that you have here. So you can paint the max distance, which is the allowed movement per vertex, both in the normal direction and the reverse normal direction. Then you've got something which is called Latch to nearest. So it's also a per vertex attribute, and that attribute, that's something you want to paint as soon as you've got a mesh which has some white on it. So if you provide a mesh which has some white, you'll have two plane surface next to each other being really close. And if Nvidia physics doesn't know anything about those, it's going to simulate those 2 planar surfaces independently, and in some situation you'll have the back part of your clothes which may collide and intersect with the front part of your clothes. So the latch to nearest tells that even if you provide some max distance value, when you're going to paint that value onto your vertex, what it will do is it will check what's the nearest point it can find into the opposite surface, and it will kind of attach to it, it will latch to it. So it's a really good way to have 2 surfaces reacting the same way when you got some meshes which has some white. I really recommend getting into the physics documentation, which is available on our download website. This is where you're going to download both the plugin, the physics plugin, because we are now maintaining it, and also the documentation, and it kind of details all those parameters with more information within it. Then you've got the backstop offset. I kind of specified earlier that when you provide the max distance, it's going to be into both direction, both the normal direction and the reverse normal direction. In some situation, you don't want to have the back to also be available to look to your clothes. You just want to have one side, so you can provide an offset being 0. And backstop radius kind of corresponds of the sphere which would act as a collider. If you provide a really large sphere, it kind of look like a planar surface for the clothes. If you provide a smaller sphere, you may have some bump, and you may see the spheres appearing here on your character. So those are the per vertex attributes you can paint. And when you're good with those, you can go into the physical materials. So the physical materials, there are plenty of those. I'm not sure if we'll go through those all of them, but I'll probably go into the the most casual one. You've got the physical materials, you've got the fiber limits, and into the advanced materials you'll have the fiber limits, but being defined per kind of fiber that you have. You have something on the length of the fiber, you have something on the cross section of the fiber when 2 edges crosses each other, when it bends, and when it shears. Once again, those are defined. You need to enable them first, and those are defined into the documentation. So let's go through maybe the most casual one and see what we can get and how far we can go with that. So first we've got the gravity scale. So gravity scales is, as the name tells, it's a multiplier that will apply to the we'll apply that to the actual gravity which is defined into the physics solver, and it's a way to make your clothes looking heavier. If you increment that value here, you'll have a heavier clothes. So not sure if that's a value which is big enough. Well, kind of. You may have noticed that when the clothes stop, it kind of stop pretty fast. It doesn't have a lot of inertia. Let's provide a really high value, see what we can get from this. By the way, as soon as you change an attribute within the UI, it will reflect right away into the viewport. So you can have a full dynamic animation and change your parameters dynamically and see how they look like. So here we provide a 10 times gravity, so it's a really high gravity, and you can see the clothes fall forward pretty fast and stop itself and collide with the ground pretty fast. So it's just a way to make your clothes looking heavier or maybe really light, and now you can see gravity doesn't have such an impact on the character. It looks really light. It has a lot of inertia being into it. So yeah, up to you to decide this. Then you've got friction. Friction's gonna comes into the game whenever there's a collision with an object. So here into our scenes, we're in collision with the ground plane, and every time there's a collision, it's gonna slow down the velocity of the clothes. If we provide a really low friction, you can't provide a 0 value, but you can provide something really low. You'll have your clothes. Oops, let's go back in time with this. You'll have your clothes which will really glide on the ground. So you may have noticed that it was much more sliding and gliding on the ground. It's like a slippery surface. It's on both sides. And if you provide a really high value, you'll have a clothes which was stop itself as soon as it hit the ground. It's kind of a really sticky surface which is retaining the clothes to move forward. When you're going to deal with this within Golem, there's going to be both a friction on the clothes, but also on the collider. So when you're going to define your colliders, you're going to say, okay, there's that box here, which is a collider. Let's translate it into a crowd rigid body. And my rigid body also has its own friction attribute. So they're non-zero by default. Here I put them to 0. They're not used into that simulation. The physics plugin doesn't know anything about the Golem rigid body object, but when you're going to do a physics simulation within Golem, keep in mind that there is also friction on that side of the collider. Okay, we've got a friction. Not sure what was the default value, but probably 0.2, something like this. Then you've got something called bending resistance. So it's going to tell how small or large a fault is. So this is based on the, well, I'm not going into too much details, but on the angle between edges along the stretch, and how much it freely bends. So let's say we provide a really low value here. It means that, I'm not sure, we'll see. It means that your clothes will not have a lot of bending resistance, and you can see it looks a bit more rigid and goes back to its previous value. If we provide the maximum value of a bending resistance, you see that it looks like more soft. There's plenty of bends all the way, all those tiny stretches and bendings happening here that we didn't have before. Let's go back with this, and now you can see it's a bit more rigid. So this is bending resistance. I think default value was 0.5. Let's go back. Then we've got shear resistance. It tells how hard it is for a quad to shear. So meaning that how hard it is to leave the quad shape that it has from the beginning. 0 means it's going to be really weak. So weak means that you will leave easily its shape. So pretty hard to see here. And 1 mean that it will be pretty stiff. And it's not a something, well, I should have say this as a disclaimer first. I'm not really, a character FX artist. So I played with those, but, I don't have a pretty enough accurate eyes to spot all the differences. But hopefully you can play with those. So then you've got, the value was 0.5 here. So, oops, no, sorry. Let's go back into, I went way too fast here. Let's go back into stretch limit now. So stretch limit means it tells you how much the clothes is allowed to overstretch from its rest length when it's stressed. So let's provide a pretty high value and also maybe provide a high gravity value so we can feel how it is. So yeah, when you provide a stretch limit, you can see that now the clothes, and that we provide a pretty high gravity stuff also, and you can see that now the clothes allows itself to stretch a lot. So we kind of left the quad shape we had from the beginning, and if we provide a 0 stretch limit, you can see that now it doesn't stretch at all. So that kind of applies whenever there's a really big stress upon the clothes being applied. So this is why I augmented the gravity here. Relax, it works in combination with the stretch limit. It increased the relax value, which means it reduced the strength of the stretch limit. So you can have a more relaxed clothes when you do something like this. So let's put this back to 0.5. Let's put this to maybe 1. the relax, put the value to 1, and apply a simulation. And once again, I'm not really sure if I'm gonna be able to spot the difference. Well, not really here, but once again, if you wear, I think we can see something when the close is animated. You can see that when the close is animated and stressed and we provide some velocity to it, it's kind of more stretched and more relaxed. So it's just a way to have something more elastic at the end. So probably play with these attributes and see how they end up with. Okay, damping is a pretty simple one. It dampens the close relative to its local movement. So it doesn't take the word movement into account. And you can combine this with drag to have a best effect if you want. So damping is super low here. So there's not too much damping on that close. So you can see and the gravity is pretty high. So let's put back a gravity to 1 again. So yeah, you can see the close looks pretty flexible. As soon as we're gonna increase the damping, it's gonna dampen all the acceleration. So it looks way more like maybe more like a blue jean or some heavy fabric rather than a soft silk fabric. So the lower the value, the more silky it will look, and the higher the value, the more blue jeany, rigid it will look. So you can combine this with drag, because drag it damps the global movement of the close. So it's based on the translation of the bone. So this is where when you have an animation, this is where you're gonna see the results. So drag here is pretty low. Let's put this to 1 value. Okay. Oh, and we probably need to provide some damping to allow drag to happen. And okay, it's also bounded to the value of your drag here, 0.296. Okay, great. And this is something you'll really see when you're gonna provide some animation. You can so okay, this is with drag, and we should provide back the drive. I usually have some more. Yeah, okay. So okay, maybe something. The takeaway of this is let's freeze on the frame, and I think I'll be able to spot the difference when we come back here. You can see that the close has a lot of inertia. This is frame 108. It really goes back following the inertia of your movement. Let's say you provide a higher drag. So that was frame 108. Let's try to freeze at the same value. 6, 7, 8. Here, well, no, okay, I can't really spot the difference. Okay, here's the documentation, what it tells. It damps the global movement of the close based on the root translation bone, resulting in something similar to air resistance. You can combine this with damping in local space mode for best effect. Drag has no effect when it's set higher than damping. Drag cannot be higher than damping. Drag is not used for global server mode. DCC enforces local space. So yeah, whatever that means, hope that helps. And finally, we've got inertia blend, and once again, this one should be pretty easy. It tells you when the local space mode is turned on, this acts as a way to blend in the effects of the global animation movement. So 0 means that it's pure local space simulation, and the 1 means that it's fully global space simulation. So if I play this, you'll see that the movement of my bone has a lot of effect of the close. Let's go back to that frame 108 that we were before. The inertia of the movement really provides a lot of animation to the close. Okay, so you've got a global movement which is providing a lot of force. If you turn this to 0, only the local modification will be taken into account, so that bone animation we are providing does not have much influence onto the character. So if we can see it's kind of going behind, and when we're going to move to frame 108, you can see that inertia is not going to be provided to the flag, and the flag doesn't go behind. So yeah, the default value was 0.5, and that's probably a good value to have depending on your situation. Whenever you have an animation, it means that half of that motion will contribute, half of that motion velocity and inertia will contribute to the closed simulation. So that's really something you want to set properly if you want to have a close reacting to your motion more or less. Then quickly just to speak about the compression, expansion, and resistance. So those are what they called fiber limits. So they are coefficient between 0 and 1 as well. Well, expansion is between 1 and 3. So the compression, it tells how much a fiber can compress, and here this will control everything, means length fiber, cross-section fiber, bending fiber, and shearing fiber. Expansions means this is the same. It tells you so compression, it means you can get a smaller value than what you have right now. Let's say our square are 1, 1, 1. Compression means that you're allowing your square to compress and get smaller, so being more elastic. Expansion means that you're allowing your fiber to be at size of 1 or 3 times higher its original size. And resistance tells what's the resistance for, so how hard it is for the fiber to try to get back to the rest length or to expand. Once again, that's something if you want to define something which is more or less elastic, how much restitution you provide into this, and then so on and so forth. Those attributes, when you export them within the APX files, they're going to be stored into this, and Golem will read those and apply them exactly to your clothes. Just part of a last tip I can provide you with, if you don't have the time to provide some animation, there's something you can do, which is into the advanced attribute. You can provide a wind direction and elevation. So you can provide this with angles and a velocity here. So it kind of helps you simulating some wind. So when you, and probably we need to provide a higher value here, wind velocity of 1000. Okay, here we go. So now I'm providing some wind value on top of the behavior. So it's just a good way for me to see how those clothes react to what's in the scene. So I can change my attribute, maybe, you know, increase the damping to see that my character becomes more rigid. Maybe my bend resistance. So it's just a way to quickly iterate without having an animation, which is fully available for the duration of this. So damping, probably a lower value here, shear resistance, and yeah, you know, I can converge into this as soon as I want. It's probably a good thing at some time to, you know, rewind the sim to go back into a nice and clean simulation. Okay, so let's see how we can provide this within Golem and how we can interact it with the same way. So let's stop the wind for a second. You're here. I really encourage, if you'd like to if you'd like to have more details regarding those parameters we just spoke with, I really encourage you to you know, take a look at the documentation. It has a complete page regarding this, so you can have more data and how you set those accordingly. So let's go back into the initial position. Let's maybe provide some value, some stretch limit here, bending resistance, something like this. Really low value of friction, really low value of damping, inertia blend, something like this looks good. Okay, and whenever I'm happy with this, I can just select my clothes, probably save my scene. I'm gonna export selection. We've covered this into the previous tutorials. I'm gonna export this as a physics asset. Make sure to check this into the physics clothing. Make sure that you are both in centimeters here and centimeters there. And I'm gonna override my flag centimeters APX file, which is currently used into my Golem character. So once again, make sure to check this to know more about this. Within my scene here, I'm creating some particles with some crowds, and I should be able to get my clothes in. And if I run the sim, now I'll have my same exact setting being applied onto my character. I reduced the friction a lot, so this is why I could see it sliding on the ground. And if I want to make sure that I'm using the right stuff, I can put something really high in terms of maybe damping. Let's see how it looks like if we do this. So okay, we've got a really high damping here. The character is kind of slowed down. So let's go back into the initial frame. Export selection once again. Override this. And see if we got, and we've got the similar simulation. Now we've got really high damping onto our Golem clothes. And yeah, it's following the same parameter than the one you've been injecting. Also, if you want to provide more colliders to your scene, make sure that you have really simplified shapes. You can have your own terrain, but use something different for the collision. Maybe let's say I want to have a collision sphere for that character here. I'm going to provide a radius of 100, so it's, well, maybe not 110. Maybe more. Let's do with 30. Okay. And if I want this to be taken into account by my behavior, also let's go back to some regular damping here. So it doesn't take ages for it to simulate. Let's go back into the first frame once again. Export my selection as a flag there. Let's see if it's taken into account properly. Okay, good. So let's say I would like to take this, my environment, as a collider. Really make sure that you can use, you know, proxy which have single shapes such as boxes, capsules, spheres, and so on, because it's way more easier for the physics system to provide and compute collisions with. So you're gonna select your sphere here, go into the Golem shelf, select as, make it like a crowd rigid body. So now you've got an approximation of that sphere, being a sphere with a radius of 30, and you can now use that new node and go into your Apex behavior, which is used to say that you want to have some physics simulation on your clothes, and select your rigid body, press shift to be able to select your behavior at the same time and map it. I was able to already map my cube into this, so this is why my clothes is colliding with the ground. And now you've got a clothes which is reacting to that shape here, and those guys here are not reacting to it. Also, just maybe let's see if we can provide some high friction here, like provide a really high friction when we are on the ground. So this is the ground rigid body, and it's kind of, well, okay, it's not really noticeable here because we've got a really low friction here, but it's kind of slowed down the clothes before, between what we had before. So yeah, that was the second video of that series going through clothing materials. Hopefully that helps. That will help you define your right fabric for your clothes. Into the next video, we'll jump into collisions with the characters. Right now we're doing flag. We don't really care about character collisions, but whenever we do a cape or a skirt, we want to have you know, all those limbs being taken into account so the clothes react to it. So we're gonna cover this into the third video. So see you into the next video, and take care.